All right, we are going to be dividing rational numbers today. It's very similar to what we did on Monday. Monday we looked at multiplying rational numbers. So today we're just going to be dividing. The first thing I want to start with is a little bit of vocabulary. We will be using the word reciprocal.
Oh, I know that. It's where you flip it. It's where you flip it over here and right?
It is.
Oh, really? So you just said it. Bully.
So the reciprocal is when the fraction is flipped. Basically, you just flip it over. Your numerator changes places with your denominator. So that's your vocabulary term. Another nice thing is that our rules for division and multiplication remain the same. If our signs are the same, our answer is positive. If our signs are different, it's negative. So all of that stays exactly the same. And one thing that we talked about before, we didn't really emphasize it, but we're going to be using it a lot here soon, is this idea that our fraction is negative. So we have a numerator and we have a denominator. If we have a situation where our fraction is negative, it means that our numerator could be negative and our denominator positive. Or it could mean that our numerator is positive and our denominator is negative. Just remember that here there is one negative, so there has to be one negative in our fraction. Doesn't matter if it's on the top or the bottom, the result is negative. It cannot equal both being negative, because now we have an even number of negatives making it positive, which is the opposite of what we want. So that does not work. Fractions can also be written in a few different ways. Things like numerator divided by denominator. A fraction is just a division problem, numerator divided by denominator. You can also write it as numerator divided by denominator, like that. And you can also write it as numerator divided by denominator. You can write it horizontally. So 3 different ways to write the same thing. Sometimes it's easier to see it in one way instead of another, and that's why we have those 3 different ways to do it. Let's have our first example be something that we did before when we worked with integers. Negative 120, we're going to divide it by negative 5. So it's written as a fraction, which means it's division. Numerator divided by denominator. Our signs are the same, so our answer is going to be positive. So let's do 120 divided by 5. 5 goes into 1 0 times. 5 goes into 12 2 times. So 2 times 5 gives me 10. 12 minus 10 gives me 2. Bring down my 0. 5 goes into 20 4 times. 4 times 5 gives me 20. 0 left over. So my answer is 24. And remember that it's positive because we have an even number of negatives. Now let's look at some complex fractions. This is 1/3 divided by 2/5. This is what's called a complex fraction. It's called a complex fraction because it's a fraction within a fraction. For this one, we wrote it using that method right there. For this one, we're going to use this method right here. We're going to do 1/3 divided by 2/5. In order to divide fractions, you multiply by the reciprocal. So our first fraction stays the same. Instead of dividing by the fraction, we're going to multiply by the reciprocal, which is 5/2. It's kind of just like same change, change. It's really similar. Instead of changing subtraction to addition, we're now changing division to multiplication. You can see where that method is kind of connected. So instead of dividing by a fraction, we multiply by its reciprocal. Now we multiply straight across. 1 times 5 is 5. 3 times 2 is 6. So our answer is 5/6. Let's look at dividing with an integer. -2 divided by 4/9. So numerator divided by denominator. I'm going to rewrite it as -2/1 because I know we're going to have to do the reciprocal. So I'm going to do -2, and then I'm going to divide that by 4/9. And I'm going to copy my first fraction, change my division to multiplication, and then I find the reciprocal of my second. A lot of teachers say copy, change, flip. Anything that I could reduce there? Molly? Absolutely. 2/4 can be reduced to 1/2. Anything else? Okay. The what? Well, the 1 and the 9, the 1 goes into 1 once, the 1 goes into 9 times, so it doesn't really get us any ground. Rizio? Yeah, so that'll be a negative. Yeah, so it's a negative times a negative, so our answer is going to be negative. That's a good, yeah, we don't want to lose track of that, you're right. And then if I multiply the numerator, it'll be 1 times 9, which is 9. Denominator will be 1 times 2, which is 2. And then that can be simplified. 2 goes into 9 4 times. 4 times 2 is 8, so 1 will be left over. So our mixed number is -4.5. All right, I got a dangerous one. 2 1/4 divided by 3/8. Now think back to when we talked about multiplication. What do you think we got to do here? Smile. Perfect. Checkmark method always works really well. 2 and 4 is 8, plus 1 gives me 9. And I'm going to copy down the division. I like doing every single step. If I start leaving steps out, I'm more likely to make a mistake, and I don't like making silly mistakes. I don't mind making big mistakes, but I like to know that it was my mistake. Anything that I can reduce, oh, hold on, I got to copy, change, flip first. So I'm going to copy down, change, and then I got to flip this over. Anything I can reduce here? This right here. Lena? Absolutely. 9 over 3, so that goes in there once. That becomes 3 over 1. Kevin?
4 and 8.
4 and 8. So 8 over 4 is just 2 over 1. So then I can multiply 3 times 2, which is 6 over 1, so it's just 6. Let's see what that looks like if I don't reduce first. So if I do 9 over 4 times 8 over 3. All right, if I don't reduce that, I'm going to do this like the non-reduced method. So 9 times 8 gives me 72. 4 and 3 gives me 12. My numbers are already pretty ugly. So I could do maybe divided by 2. Divided by 2, that gives me 36 over 6. And then I could divide by 6. Divide by 6. That'll give me 6 over 1. Which method is easier? Yeah, definitely the first one is easier. We can reduce first. Dealing with 72 divided by 2 is a lot harder than just doing 8 divided by 4. So it's definitely a more economical way. Let's look at one more example. This one dealing with decimals. 4 and 2/10 divided by 2 and 4/10. Now, before we divide this, I want to remind you about equivalent fractions. I'm going to make some equivalent fractions down here. So 1/2, in order to make an equivalent fraction, I can multiply by 10, multiply by 10. So 1 times 10 is 10, 2 times 10 is 20. These are what are called equivalent fractions. 10 over 20 is the same amount as 1 over 2. They're equivalent. Notice when I multiplied by 10, my decimal just went one place to the right. So when I'm up here, I can multiply by 10, multiply by 10. My decimal will go one place to the right, making this 42 over 1 to the right, 24. These are equivalent fractions, just like these are equivalent fractions. They don't look like it, but they are. Yes?
So could you like instead of having like 4.2, could you like make it like 4 and 4 over 2 and then 2/4?
Good question. So she wants to know, can I just like separate these two fractions to make that fraction there and then that fraction there like that, right? Cannot do that. It would be like taking this right here and making it 12 divided, where am I at? Oh, you can't see that. If I made it like this and I said there's 1 divided by 5 and then 20 divided by nothing. It doesn't really work that way. So what I do have to do now is numerator divided by denominator. So I'll do numerator, denominator. 24 goes into 42 once. 1 times 24 is 24. Gives me 12, 3, 12, 11, 10, 9, 8. 3 and 2 is 1. Annex is 0, so put a decimal out there, bring it down. 24 goes into 18 7 times. 7 times 4 is 28. 7 and 2 is 14, 15, 16, so that's 168. It's out of 10, makes out of 7, so 10, 9, 8. 7 and 6 is 1. Annex another 0, bring that down. And I think it's 5. 5 times 4 is 20. Yep. 5 times 2 is 10 plus 2 gives us 12. So our answer is 1 75/100. Yes, ma'am.
So if you have like a decimal and it has like 2 spots, so you have 2 numbers after the decimal, and then when you move it to the right, so you do
So if I have this, to make these even, I move it 1, 2 to the right. This one I move 1, 2 to the right, so then it becomes 135 over 320. Just move it however far you need to move it. Because you can think about it like this. If it's 1 over 2, I could move it 1, 2, 3, and then I have to move this one 1, 2, 3. And it would be 1,000 over 2,000. It still reduces down to 1/2. Yeah, yeah. Any other questions about the division?